Determining the probabilities using areas under the normal curve. The probabilities that the value of z from z distribution, just like this one, will lie within a given interval are presented in a table of areas under the normal curve. For example, in this table, we have areas under the one-tailed standard normal curve. So this is the graph of z distribution because this is standard normal curve. Now, for example, if z is equal to 1.45 and we want to find the area under the curve from the mean 0 to z is equal to 1.45, we just need to find 1.4 first here in our first column, and then to make it 1.45 we need to add 0.05. So 1.4 plus 0.05 is 1.45, and we'll get the intersection of the two. So the answer is 0.4265, meaning to say that's the area under the normal curve from the mean 0 to the z-score 1.45. Example number 1. The weights of the students in a certain year level are normally distributed with a mean of 60 kilograms and standard deviation of 3.5 kilograms. Find the probability that a student randomly selected from this group weighs less than 55 kilograms. So first, 55 kilograms will be our x. Mu, the population mean, is equal to 60. And then standard deviation is 3.5. Following this formula, converting x to z-score, we have 55 minus 60 over 3.5, which is approximately negative 1.43. So if the normal score or x is 55, z or the z-score is negative 1.43 in this problem. So graphing that, we have probability of x is less than 55 is the same as probability of z. So normal score, z-score. Probability of z is less than negative 1.43. So in graph, we have, because we have this one, because the middle number is the mean, which is 0. So left side of that mean is negative 1.43. And less than negative 1.43 is this shaded part. So probability of that is the area of this shaded part. So the problem is to find the area of this shaded part. How are we going to do that? We have this table of one-tailed standard normal curve. So using this table, we find the area between the mean and negative 1.43 is the same as 1.43 because normal curve is symmetric. The left side is the same as the right side. So the area is equal to, so 1.4 plus 0.03 is 1.43. The intersection is 0.04236. So the area from the mean 0 to 1.43 is 0.4236. And because the graph is symmetric, the area from the mean to negative 1.43 is the same, 0.4236. But that's not our problem. The problem is to find the area of this shaded part. And how are we going to do that? Because half of the graph is 0.5, or the area is 0.5, we subtract 0.4236 from 0.5. So 0.5 minus 0.4236 is equal to 0.0764, and that's the area of the graph or of the shaded part. Therefore, the probability that a student randomly selected from the group weighs less than 55 is 0.0764 or 7.64%. Next, let x be a normal random variable with the mean mu is equal to 550 and standard deviation of 150. find the probability that x will have a value greater than 600. So earlier is less than. This time it's greater than. So x is equal to 600, mu is 550, and standard deviation is 150. Following again the formula, converting x to z, we have z is equal to 600 minus 550 over 150. And the result is approximately 0.33. So if the normal score or x score is 600, z score is 0.33. So this is 0.33. This is our middle term. 0, that's our mean. And then 0.33 is here. Now since we need to find the probability that x is greater than 600, which is the same as z is greater than 0.33, the graph is to the left, to the right of 0.33. Shaded part to the right of 0.33 under the normal curve. Now we need to find this shaded part to solve the problem. Using again the table, we have 0.33, 0.3 first, and then 0.03. Adding that, we have 0.33, and the intersection is 0.1293. So that's the area, 0.1293. So which means this part here, from the mean to 0.33 is 0.1293. Now in order to get this area of the shaded part, we subtract 0.1293 from the mean, from 0.5, because half of the graph is 0.5, and the result is 0.3707. So the shaded part is 0.3707, which means that the probability that x will have a value greater than 600 is 37.07%. Example number 3. It is known that the weights of mangoes harvested in a farm are normally distributed with a mean of 220 grams and standard deviation of 25 grams. If a mango is selected at random, what is the probability that its weight is between 180 and 250 grams? So there are two x's here, two values of x. We have x of 1 is 180, and then x of 2 is 250. Same thing, population mean is 220 and standard deviation is 25. Now we have z sub 1, that's for x of 1, is 180 minus 220, which is 25. So meaning to say, if the normal score is 180, the z score of that is negative 1.6. And if the normal score is 250, the z score of that is 1.2. What does that mean? We need to find the probability of having x between 180 and 250, or probability of having z between negative 1.6 and 1.2. So this is the graph. Negative 1.6 is somewhere here. It's between negative 1 and negative 2. And then 1.2 is somewhere here. It's between 1 and 2. Now, between the two numbers is the shaded part. That's what we mean. So we need to find this shaded part, the area of this shaded part. Using the table, we have negative 1.6 is the same as 1.6. So 1.6 first is 0.4452. 0.4452. And then 1.2 is 0.3849. Plotting that in our graph, we have 0.4452. It's between 0 or negative 1.6. And then 0.3849 is between 0 and 1.2. What shall we do to get the area of the shaded part? We add. So between negative 1.6 and 1.2 is 0.44 plus 0.3849, and that is equal to 0.8301. Which means if a mango is selected at random, the probability that its weight is between 180 and 250 grams is 83.01%.